In this video, we are going to look at combining functions in each of these four ways and the resulting domain of each function. So first we will start with the functions f of x equals x squared plus 9 and g of x equals 4x plus 16. And we're going to look at f plus g of x. Well, we get that by just taking the function f and adding the function g. So we have x squared plus 9, that's not a plus, that's a minus, plus 4x plus 16. Now, since this is addition of polynomials, these parentheses aren't really necessary, so we can just ignore them and combine like terms. I only have one x squared term. I only have one x term. But I have a negative 9 and a positive 16 gives me a positive 7. So, f plus g of x is equal to x squared plus 4x plus 7. What is its domain? Let's come back to that. I claim that the domain of all three of these is going to be the same. So let's wait until we've found f minus g and f times g before we look for the domain. F minus g of x is going to be f of x minus g of x. And this time, since that's subtraction, we are basically multiplying everything in here by -1, so I need to distribute that -1. We have x squared minus 9 minus 4x minus 16. And now we combine like terms, and we get x squared minus 4x. -9 minus 16 is -25. F times g. That is just going to be f of x times g of x. And here we have to do all our distributions. X squared times 4x is 4x cubed. X squared times 16 is 16x squared. 4x times -9 is -36x. And -9 times 16 is -144. And so this 4x cubed plus 16x squared minus 36x minus 144 is f times g of x. So what's next? Let's find the domain. The domain of these three is just going to be the intersection of the domains of f and g. In other words, it is going to be whatever is in the domain of both. Well, both f and g are polynomials. The domain of f is equal to all real numbers, and the domain of g is equal to all real numbers. So, the domain of f plus g is the same thing as the domain of f minus g, which is the same thing as the domain of f times g, which is where these two match up, which is everywhere, so that is just all real numbers. Things get a bit more fun when we do f divided by g. Well, this is just going to be f of x over g of x. And we should make sure this can't simplify. We do that by factoring the top and the bottom. So we have x plus 3 times x minus 3 over 4 times x plus 4. We have no common factors, so we can't simplify this. So this is f divided by g. And what is the domain of this? Well, it is going to be wherever f and g cross, wherever their domains both exist. But we have to exclude any time when g of x is equal to 0. So we need g of x cannot equal 0. So where does this denominator equal 0? Since we've already factored it, we can see that g of x will equal 0 when x is equal to negative 4. So we need to exclude that from our domain. Or another way to write that, g of x is not equal to 0 when x is not equal to negative 4. So as long as x is not negative 4, we are good. So we write negative infinity to negative 4. We use this parenthesis to say we are not including negative 4, a union symbol. And then negative 4 to infinity. And again, this parenthesis means we are not including negative 4, but we're including anything bigger than it and anything smaller than it, just not negative 4. Okay, let's try this again with two new functions. Now we're going to let f of x equal the square root of x and g of x equal x minus 19. Well, first of all, we might notice fairly quickly that there are no common terms. There are no like terms between these two functions. So if we do f plus g, f minus g, or even really f times g, there's not much we can do to combine it and make it look nice. So we're not going to do that many of those. And since they all have the same domain, there's no real reason to go through all of them. So let's just do f times g of x, which would be f of x times g of x, which we can multiply that through. It doesn't look much prettier. So we have x times the square root of x minus 19 times the square root of x. Then we ask, what's its domain? Well, as before, we need to know the domain of f, and we need to know the domain of g. And as before, g is just a polynomial. Yes, a linear function is a polynomial. So its domain is all real numbers. F, however, is different. This is a radical function. It is a root function. And it's a root function with an even index. We don't see it, but that's a 2 here. Which means we need the inside to be greater than or equal to 0. Luckily for us, the inside is just x, so our domain is any x values greater than or equal to 0. And we put this square bracket here because that square bracket means we include 0 and everything bigger than it. So the domain of f times g is wherever these two domains overlap. Since g is everything, they overlap on all the non-negative numbers. So the domain of f times g is going to be 0 to infinity, including the 0. How about f over g? Well, that's going to be f of x over g of x. Nothing to simplify, so that is our function. And again, we'll look at the domains. We do need to start with where they overlap. So we're going to start with 0 to infinity as our domain. But we have a problem. We also cannot let g of x equal 0. And can that happen? Well, yeah. If x is 19, we have 19 minus 19 on the bottom, which is in fact 0. So we know x cannot be 19. The next thing we need to check is 19 in this basic domain? So we started with this domain, and if 19 is in there, we need to exclude it. If 19 is not in there, we don't. Well, 19 is there, so we're going to write our domain as 0 until 19. Do not include the 19. We're skipping over it and going to infinity. One final note, we had instead had h of x, which was x plus 19, then f over h of x is going to be the square root of x over x plus 19. Our basic domain is that 0 to infinity because that is x, while h has a domain of all real numbers. But we can't let h equal 0. So that means we can't have x plus 19 equal 0. So x cannot equal negative 19. And we ask, is negative 19 in this domain? No, which means this domain already works for us. So the domain of f over h is going to be 0 to infinity. Thank you for watching.